Good morning, good afternoon, and good evening, wherever you are. We appreciate you joining us today. My name is Zane Hamilton. I'm the Vice President of Sales Engineering here at CIQ. For those of you who are unfamiliar with CIQ, we are a company focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in a collaborative spirit of open source. Today's webinar, we're going to dive in and talk about containers. And we have Forrest Burt, Dave Godlove, and Jonathan Anderson joining us. Hey, guys.
Hey, everyone.
Hey, Zane.
Welcome back. It's been a long time. So let's go ahead and do a quick round of introductions. Forrest, you're on the top right, so I'm going to let you go first. Tell us who you are.
Howdy, everyone. I'm Forrest Burt. I'm an HPC systems engineer here at CIQ, and I'm excited to be on the webinar today. So thank you for having me.
Thank you. Jonathan.
Yeah, my name is Jonathan Anderson. I am an HPC engineer with CIQ, and I'm also excited to see what Dave has for us today.
And of course, the man of the hour, Mr. Godlove.
Hey, everybody. I am a solutions architect at CIQ and been around the Apptainer Singularity community for quite some time, and I'm excited to talk to you about building containers today with everybody here.
It's fantastic. Again, welcome, guys. Dave, I think it's time for you to dive in and start talking to us about building containers. And you're still on mute.
Oh, wait, did you want me to do something?
Maybe. I mean, it might be okay. If you just want to sit here
Yeah.
and Jonathan and Forrest and I talk and you sit around, that's fine too. It wouldn't be much of a container discussion if I'm involved. But
sorry, I'm trying to share my window here real quick.
it's all good.
Yeah, so let's just dive right in, like you said. A couple of weeks ago, we did an introduction of Apptainer where we talked about look and feel of Apptainer and a lot of the different features of Apptainer. And now we want to do a little bit more of a deep dive and get more into like building containers and how you build containers. So what does it mean? I want to start off very philosophically, I think. What does it mean to actually build a container? This could mean a lot of different things, but I think today, for our purposes, I want to say that building a container is anything that ends up giving you a SIF file, a Singularity Image Format file. That's the file format that we use for containers in Apptainer. So by that definition, let's see, you could really do something like, let's do something like this. Is this building a container? So when I pull a container from like a container registry, like this library that I've got configured, I end up with a SIF file. So you could say that that's building a container, right? Well, really, we typically kind of think of that as downloading. You just download a SIF file, and that's really all you're doing.
Come on, Dave, you're breaking my heart here. That's how I build containers.
Well, let's look at another example. Zane, I think that there still is hope for you as far as building containers.
I don't know about that, but
let's look at another example. So I'm using the pull command, and now instead of pointing at this library image, I'm pointing at Docker instead, right? And so let's think about what's really happening when I pull this container from Docker. What really happens is that I download a bunch of different layers, tarballs is what they really are. And all those tarballs are then untarred, and then I use overlay.fs to take all those tarballs and smush them together and make a single coherent file system out of them. And then I take that file system and I compress it into a squash.fs file system. And then after that, I put that into a SIF file. So even though we're just doing like a little simple build command, really, or I'm sorry, a little simple pull command, really this is building a container, okay? This is taking a bunch of different pieces and putting them together and making a container out of them. And in fact, the reason that I'm going through all this is, a lot of times people won't do this. You won't really think about doing something like this, but you could actually just build your container like this from a URI. And this is syntax that I think a lot of people are probably not so familiar with, but it works just fine. Apptainer is quite happy to build your container like this. And if you actually looked under the hood to see what was going on, you would find that Apptainer was traversing pretty much exactly the same code path when it did this as when you were doing the pull. So this is, I introduced this to talk about the differences between pulling and building and the similarities actually between them, and also to talk a little bit about building from different sources, right? So right now we have pulled or built or whatever you want to call from the library. We've pulled and built from Docker Hub. You can actually so these URIs and when we start talking about building containers, these are actually, we're going to start talking about these as Bootstrap Agents. So these are agents that you use to start building your container from. You can also build your container from pre-existing containers, which are right there on your file system. But since I just built this container, I now have this Python CIF container here. And you not only can you build CIF files, but you can also build sandboxes, right? You can build directories, which are just, they're just bare directories and they contain a file system in them. So since you can do both those things, you can build from a pre-existing container, which is sitting on your disk, and you can also build to a sandbox. You can use the build command to just kind of switch between different formats. So let me show you how that works. I'm going to go ahead and just build a directory called Python from this python.cif, very simply like that. And so now I've got this directory called Python, and if I look inside of it, it's a root file system, right? So that's a kind of a nice trick that you can use to debug your containers if you're not sure where something is in your container. It can actually be difficult to find things if you shell into the container, and I'll give you a specific example. Sometimes people install things in the container in root, and they do so because it's not, an unusual thing to think that somebody might run the container as root, especially if they're using Docker. So they'll have access to anything that's installed in root. But if you're running a container that was built using Docker via Apptainer, then you're not going to have access to the root directory because you just don't have permissions to do that when you enter the container. You could enter the container as root, but if you do that, by default, your home directory as root on the file system gets overwritten into the container at runtime. And so it can be very difficult sometimes to sort of figure out where things are installed because of that. So you can just convert your container to a sandbox, and you can just look in here and say, okay, is there anything in root? And in this particular one, there's not. This is also a cool trick that you can use if you're just trying to figure out how to build your container for the first time. So you can do something like, now that I've got this as a sandbox, I can shell into it with writable. And then I can do things like, I can update the container. I can install things into it. And so say I'm trying to install something for the first time. It's got a bunch of dependencies. I don't really know what all it needs. I can noodle around in the sandbox, and then I can record whatever I do in the sandbox in a definition file, and then go back and use this as a substrate to figure out how to build my container, right? So I'm going to go ahead and install Vim. Now, because I told you that you can swap back and forth between different formats on disk by using the build command, you might think, okay, great. So now I can go ahead and build a new CIF file from that directory that I just created. And you could do that. So now I've installed Vim inside there and I did an update. And so now the container is a little bit different. but it's not considered a best practice because if you do this, you're not going to have any record in the container in terms of a definition file, which we'll be talking about later, of what you actually did. So you won't have any record that this container was updated, that Vim was installed, anything like that. So in general, if you're going to noodle around and try to use this as a development substrate to build a new container, you probably want to record all your changes in a new definition file and then use that ultimately to build your new container.
So Dave, would you say this is a good way to just test? So going through, you're building your definition file, you build it from that file system, you test it. That way you know that it works and you're not having to rebuild every time or change your definition file every time. You're kind of playing.
Yeah, so one thing that you might do is shell into the container. You might have like two windows open. This is a way that I develop quite a bit. So you'll have two windows open. One of them will have your definition file, and the other one will be this one in which you're interacting with your container. And you'll be trying things here. You'll be like, try this, try that. And you'll continue to do things and record the things that work in your definition file until you break your container, right? And then you'll build your new container from your definition file, shell into it again, and continue to noodle around with it, recording as notes in your definition file what works, and continue to do that until you ultimately have everything that you want to have installed. You've got your definition file, you build it one more time, and then there you go.
Very cool.
All right, so let's talk about definition files. Okay, so I've got a definition file. I'm going to go ahead and just remove all my Python stuff. I've got a definition file here called example .def. Let's go ahead and look in this. I've been noodling around with it, so I've got things uncommented right now. Let me go ahead and just comment everything. All right. So a definition file, this is an example definition file, which basically has pretty much all the commonly used sections in it that you would use to build a container. A definition file begins with a header, and then after the header, it has a lot of sections, right? And I've got all the sections commented out right now so that in this particular instance, none of them are going to run when we begin. So here in the header, this is where you tell Apptainer what is the base container that you want to start off with. And here I mentioned earlier the concept of a Bootstrap agent. This is where you specify what is the Bootstrap agent that I want to use. And then depending on what Bootstrap agent you have here, you'll have different keywords that you can add to your header, right? So here I'm saying I want to bootstrap a container from Docker Hub. That's what the Docker Bootstrap agent means. And then I'm saying I want to start from Ubuntu. Now this syntax might be a little unusual to most people that I'm using here. And most people might be more familiar with something like this, or some tag here. I don't know if this is actually a tag. I'd have to look on Docker Hub to see, but it might say something like this. The reason I'm trying to highlight this particular syntax is because if you just bootstrap from the latest of a particular image, then obviously it's, that latest one might change. And so if you run the same definition file to build a new container tomorrow, it might not be the same as the one that you built today. That's true pretty much for all tags. So while it's not a best practice, developers can swap tags with new containers anytime they want to. So if you can actually use a SHA-SUM to specify that I want this particular image, and that's the only one that I want. And if you do that, then if a developer removes this image from Docker Hub, you'll get an error that says, hey, I can't find this image anymore. And that will alert you that things have changed. You won't get just like silent errors. You'll get a more specific error telling you, hey, this is not going to work anymore. You need to have a plan to move forward. Okay, so that's the header, and we're going to talk more about different Bootstrap agents, hopefully later on if there's time. But
I'd like to say one other thing about the benefit of using a SHA there. You're pulling these down, from the Docker, like the normal docker.io registry. But with the SHA there, you could point it at a different registry and know that you're getting the same container no matter where it comes from, which is also a pretty cool thing.
That's right. Yep. Okay, so I'm going to start going through the sections too here. So we'll talk about different Bootstrap agents and different headers later on. Right now, I just want to cover all the sections. So the most common section that you'll see in almost every definition file is this post section. And post is called post because it runs after. And so it's post something. And that something is that it's going to download your container. It's going to jump into the container. And so after the container downloads and after the container is created, it's going to jump into the container and do this. And so this is just some bash scripting. It's just a little scriptlet. So anything you can write in bash, pretty much, you can write in post. Here, I'm setting the environment variable Debian front end to non-interactive. This is going to ensure that apt doesn't prompt me for any input when I use it. And then this is kind of silly. I'm just going to set this package variable to wget, and then I'm going to use apt to install the package. Okay. So start off pretty simply. When I build it, I'm going to use this fake root directive, and I'm going to use force, which means if this container already exists, just go ahead and overwrite it. It doesn't exist right now, but I'm going to build the same container over and over again, so might as well just start using force.
If you don't use force, Dave, does it just overwrite it or does it just error out?
It doesn't either. It actually prompts you and says, it gives you a little yes/no prompt and says, are you sure you want to do this? Okay. And so you can just hit Y. I can show that to you later if you want.
Dave, is the post section always like explicitly and definitively bash or Bourne shell, or can you tell it to use different shells? Do you know?
That's a good question. So it used to be. So there have been iterations of Apptainer, and I don't know if the current iteration is like this, but there have been iterations of Singularity / Apptainer that allowed you to specify. I don't know about specifically post, but the run script, for instance, you could specify a different shebang. And you could use that to do things like create a run script that was written in Python. I don't know if the current version of Apptainer still does that or not. I'd have to do some tests to figure that out. So I'm not prepared to say definitively right now.
Sure. All right.
Cool. Okay. So it went through, and everywhere you get a little plus sign here, that tells you what you actually ran during your post section. So I set the environment variable, I installed wget, and then it created the CIF file. And so now if I did something like sec, just to make sure wget's actually there. Yep, then I can use it. Okay, so that's pretty straightforward. So this is analogous. That post section is analogous to anything that's prefaced with the run directive in a Docker file, right? Okay, so now I'm going to go through the environment section. That's another very common section that you'll see. I've explicitly created the same environment variable in environment as I've created in post. And I've done that to highlight that these two are fundamentally different. So if you create an environment variable in post, that environment variable will be available to you at build time, but not at runtime. And vice versa. If you create, this foo equals bar, that's not going to be available during build time. So I just wanted to highlight that. And then also you'll see LC all equals C quite a bit in the environment. And that's basically just setting your locale. There are different things like Perl and some Python packages which care about how the locale is set. And this is just a simple way to sort of set it generically and make sure that you don't get warnings and errors and things of that nature. Let's see. In the interest of time, let me go ahead and uncomment a few more of these before I go ahead and build this. I'll go ahead and uncomment the next two and explain what they're doing. Okay, so here we have a run script section, and this is once again just as, and I should also highlight that here in the environment section, this stuff actually gets run. This is a scriptlet also which runs. So typically, you would just set environment variables here, but you can actually, you can do other things here as well, although it's not really considered a best practice to do it here in the environment section. If you want your container to do something dynamically, you should probably put that in the run script. So
Hey,
now
Dave,
we've
on
got
those
this run
environment
script.
variables. Sorry, I got a question on the environment variables. Can you overwrite those on the command prompt? Can you overwrite what those variables are as you execute a container?
Yes, you can. You can do that, and in fact, you can do that. Let's see. There's a special environment variable within Apptainer that will you use it to inject environment variables into the container at runtime. And then there are special environment variables that you can use to prepend and append to the path at runtime if you want to change those as well.
Okay.
So yeah, there are ways to change these at runtime if that's what you're looking to do.
Okay. Yeah, I've run across containers before where that was nice to be able to do.
Yeah. So the run script is just like a little scriptlet. So you're just going to write bash here, or if you change the shebang to something else. Changing the shebang in the run script is not as easy as just writing a new shebang here, I should say. You have to, I actually forget off the top of my head how to do it. I should have brushed up on that before doing the demo, but you can, I'm pretty sure with the current version of Apptainer, change that. And then the files.
Out of band, we've had it confirmed that you can, but not.
Yeah.
Not
okay, cool. I haven't messed around with that since Apptainer was like in the 2X series, I think. But that's something that actually I fought really hard to have included. The file section, you basically just put a path to a file on your host system, and then a path to your file within your container, and it copies files from your host system into your container at build time. So that's basically the syntax there. Let me go ahead and run this again, and then we'll have a look at what's going on inside the container. All right.
While that's building, Dave, you mentioned that the environment section is a scriptlet similar to Post. The one place where I've used that to, I think, good effect is if I install HPC applications inside of a container and it comes with LMOD module definitions inside of it. I used environment to load environment modules and then load those modules into the environment so they would be ready for the run script to run. And to do that, you source, an lmod.sh or something like that. And I was pleased to discover that that worked just exactly as I wanted it to.
Cool. That's a very cool and creative use of the environment section. That's one of the things I like about Apptainer is that, yeah, there's like the best practices of how you can use it, but then it's flexible. There's other ways, there's other things that you can do with it. So I used the files directive to copy a file called Too Many Daves, and that's just a little Dr. Seuss poem. I decided to include it because there are lots and lots of Daves in the Apptainer Singularity community in particular, but everywhere. So I thought that would be funny.
I also like how you left it. Too many days. I like how you also left the file too many days.
Right. Okay. So I'm going to jump in this example.cif file. And so right off the bat, so that Dave's poem, that's what I copied it to with the file section. So now that's there. Yes, they do. Yes, they do, Dave will do it. So I went ahead and what else did I do? Well, I set some environment variables. Let's have a look at those really quick. So foo actually got set appropriately. I trust that the others did as well. I also created a run script, and I want to show you where that ends up and where the environment variables end up. So if I cd to the root in my directory, and then there's actually a hidden directory here called .singularity.d. So now we're going to start getting into a little bit more advanced stuff. So this .singularity.d directory is actually where like the configuration for the container itself lives within the container. So if I look at that, I can see this thing called Singularity. I can see a directory called env. I can see something called run script. Let's look at that really quick. So that's the run script that I put into the definition file. Notice it's got this shebang here. So by default, that shebang is added for you. That's why if you add your own shebang at the top of the run script, it won't do anything. It'll just add the shebang underneath. So you actually have to change. I think it's a directive that you add to the end of your run script section. But so anyhow, that's where that ends up. Let's look at the env subdirectory here. So this is a whole lot of just little scripts. And what these little scripts do is they set up initially the base environment, so what the path ought to look like. If you've imported this from Docker, it takes the environment variables from Docker and it actually puts those in. Here in 90, that's actually where the environment variables that you've put in yourself end up. Okay. And so what happens is when you run the container, all of these scripts get run in order and it layers up the environment variables. And the one you were talking about, Zane, at runtime, you might actually inject other environment variables. Well, those get written into this script, I'm pretty sure, and then get sourced last so that they overwrite anything which was sourced here in the environment. And then there's some other stuff here too that has to do with like apps. You can install multiple different apps, and there's a whole kind of way to do that within a container. I'm not going to go into that, but that's a pretty cool feature that we've had in Apptainer for quite some time. But yeah, so that's how the environment works. And then there was this kind of mystery file called Singularity here. Back when Apptainer was still called Singularity, like everything in its brother was called Singularity. And this happens to be the definition file that was used to create this container. So this is how you always have a record of what was used to create the container when you build it. And it's worth noting too that even when you do one of those pull or build commands with Apptainer, under the hood, what happens is that Apptainer translates that command into a little short definition file and uses that to create your container. And it will actually jam that definition file into this Singularity file, so you can still see that you used the Docker Bootstrap agent and you got it from the following container, for instance. Okay. All right, let me go ahead and just go through some of the rest of the sections here. Okay, I'm gonna just go ahead and do the next 3 sections. So labels is a section that you can use to put just arbitrary metadata into the container. So this stuff doesn't actually end up in the container itself, but it ends up in the CIF file, and so you can use this to do things like declare your authorship or what version of the container it is or whatever. The help directive, the help section, is not actually a scriptlet. It is just text, just straight up text. And whatever you put in there, if you use the run help command with the container afterwards, it will display this text to you. So you can use this to, give your container some help for users down the road. And then test is an interesting section. Test allows you to, so when the container builds, at the conclusion, whatever is in this test section is just going to go ahead and run, unless you specifically tell it not to when you build the container. And then after the container is built, at any time, you can go ahead and run this test section again. So maybe that'd be, if I just do it, and that'll make more sense.
So I have a couple questions about that, Dave. The first is, do you happen to know if the authorship and other metadata is included in this the signed payload for if you sign a container?
Yes, it is.
Yeah, it is. Okay.
Yeah.
It would make sense to
shows-
me, but okay. My second question is if the test scriptlet changes, like makes a change to the file system, if it writes something out, will that change get captured in the final container, or is that discarded?
That's a good question. I don't think it can change the file system.
You think it's read only
I'm
by that
going to
point?
pretend that it can. Yeah, because I think that at that point, the container has already been created, and I think the test gets run probably without, well, I don't know. It probably can't change anything that's root owned because it probably just runs with normal permissions. That'd be an interesting thing to play with. I don't know.
Okay.
Okay, so at the end here, we now have extra info telling us that we've added labels. We've added a test script. We are running the test script. It tells us that yes, wget has been installed. If I want to run that again, I can do something like test wget has still been installed. Yeah, so the test script is added and is run before the CIF file is created. So at that point, the container is not immutable. This is why I'm kind of thinking about your question. I'm not totally sure whether you could alter the file system with it or not. That's a good question. So it's something to play with. Okay. I wanted to show you what the labels look like really quick. So if you wanted to inspect the container for labels, so your container ends up with a lot of metadata, just whether you put it there or not. And this is all called org.label schema. This is OCI formatting. This is why it looks like this. But you can see that I added some arbitrary metadata as well, the version of the container and username or my email address. And then finally, you can run help on the container. And all that text that you put in the help section will just go ahead and get outputted. So you can, for future you or for somebody else, you can go ahead and, put all that in there so that the container is well documented. Okay. Do we have any questions about that stuff?
Not yet, Dave.
Cool. All right, so now I'm going to get into some dicey stuff that you probably don't want to mess around with. These are not, it occurred to me after I was putting this together that there are a few other things you can do with definition files, which I'm not really covering today. One of those is there are keywords that you can use to set up different apps. You can use, I don't know how widely this is used, but you can actually, it's a pretty cool feature. You can install multiple different apps in your container, and you can do so in such a way that you can actually use Apptainer. The Apptainer itself is made aware of the different applications which are installed in the container, and you can call the different apps through Apptainer itself. Okay, that's whole other that would take a long time to go through. So I encourage you to look at the Apptainer documentation. It's pretty well documented, and it's a nifty little feature. And then another thing that I'm not going to be covering today that you can do is multi-stage builds. And the idea there is that, let's say you've got some complicated, build tool chain that you have to install to compile some code in the container, but you don't want that in the ultimate container because it's just going to be bloated and, whatever. You can create one container that has all the build tool, the build tooling installed in it, compile your code, and then in the same definition file, create another container, which has all the libraries and stuff that you compiled against or whatever it is that you need, and just dump that compiled executable into the new container. And, basically just throw away the first container. This is used in Go quite a bit. This is a pretty, common and straightforward thing that most people who use Docker are already familiar with. So Go creates statically linked executables, usually by default. And so a lot of times you'll just compile some Go code, and then you'll just take the resulting executable and dump it into a bare or very svelte container. And then you've got a container that just basically runs that Go executable, and that's it. Once again, check out the Apptainer documentation. It's really well documented how to do those things. Now I want to talk about a couple of sections which are not really very widely used, and when you would and wouldn't use these. So setup is pretty much legacy. Setup runs on the host system, not inside the container, and it runs after the container's been downloaded. It used to be that if you wanted files to go from your host system into the container, you would use setup, and that was pretty much what it was for. Since then, the files section has been added to the definition files, so setup is pretty much not really used anymore. And it's kind of dangerous, and I'm going to show you why it's dangerous in a little while. So you probably shouldn't use this unless you've got some weird corner case that you absolutely have to do this. Free can also be a little bit dangerous because it also runs on the host, not in the container, and it runs actually before the container gets downloaded. So just like post means after, pre means before, and it's before the container is actually downloaded. And once again, this is something, obviously, since it runs on your host system, it's a little dangerous to use. But there may be some places in which you really do want to use it, and I'll show you why later on. Okay, let me go ahead and build this again. There we go. All right, so now we are doing that pre-scriptlet, and it's echoing. Whoop, don't use that because that's what I put in pre, unless you know what you're doing. And then it's sleeping for 3 seconds, so we've got time to read that. Then it tried to do that setup, and it said it failed because you got permission denied. Now, okay, why the heck do I have permission denied? I ought to be able to create a file called /made by setup, right? All right, well, I ran this as fake root. Maybe I should just run it as real root. Work, darn it. Okay. So now, hopefully, it's going to let me create this made by setup file in my container. Wouldn't that be wonderful? So it's going to go through and do all this stuff. I think I'm getting messages to the effect that I've been fired.
There were too many Daves. We had to get rid of some of them.
It makes sense.
Links to official name change forms.
Yeah, people don't like awesomeness.
It's true. It's intimidating.
All right. So this time, hopefully, my container worked. My internet's being slower now. So whatever. Internet. Okay, so now I should see inside my container that it made that file that I was supposed to be able to make. It's like made by setup or something I called it. And unfortunately, I don't see it here. Wonder why not. That's irritating. Oh, wait a minute. Let me look at my root file system of my host. Oh, crap. So I've got this file called made by setup now at the root that's owned by root that I made with a definition file. And that's why, setup and pre are a little bit dangerous because they run on your host system, and sometimes you build containers as root. So if I had decided to delete a bunch of stuff, for instance, I'd be in big trouble because, especially if this was a host system that, I really used a lot and cared about and everything. So anyhow, you probably shouldn't use those. Let me go ahead and just remove this. Okay. Any questions before I get into talking about different Bootstrap agents?
I think you mentioned that more than setup, there were instances where you might want to use pre. Did I miss that, or did you talk about some reasons to use it?
No, that's foreshadowing.
I see.
So
That's
you're right.
upcoming.
You're right.
Okay.
And yeah, so as I start talking about different Bootstrap agents, pay attention because there is one in which pre becomes kind of important.
Cool.
And I think it's pretty interesting. It's probably one that people don't know about very much. Okay, I have here in my directory this directory called Apptainer, and this is the Apptainer source code that I just grabbed directly from GitHub. So you can grab this too, and if you go into it, you'll see that there is a subdirectory called examples. And examples has all these different short little definition files. Mostly what they illustrate is different Bootstrap agents. So rather than just like write a whole bunch of these myself, I decided to just use this directory. I've written a couple ones that aren't highlighted here very well, and that I should probably, I guess, make some pull requests and try to highlight those a little bit better. But for the most part, this is a pretty nice and complete library of different Bootstrap agents that you might use. All right, I've already talked in depth or shown you in depth the Docker Bootstrap agent. This grabs things from Docker Hub, right? And so that makes sense. In this case, we're grabbing the official BusyBox latest one. Let me show you. There's also a library, so you can configure. Apptainer to point to a library, and a library is a container registry which contains native CIF files, which is pretty cool. So instead of grabbing something that's a bunch of tarballs like an OCI format, you can actually grab things that are native CIF files. And so that's what this looks like. This particular one points to the Scilabs library, and they're grabbing the Alpine, the official Alpine 3.11.5 container here. There's another cool one that allows you to interact specifically with CIF, and that Bootstrap agent is called ORAS. ORAS is a OCI method for storing arbitrary data in an OCI or Docker style registry, which is cool because it means that you can store CIF files in an OCI registry. So in this case, we're using the ORAS Bootstrap agent to download a container from GitHub, the GitHub container registry right here. So you can grab their stuff up on the GitHub container registry. You can use that yourself to store your containers, and then you can grab them and use them as base containers to build your containers from. Pretty cool. Okay. Then we also, so there's another cool one that I want to talk about. Another one, I think this one's a little bit less known. We don't actually have, I think this is one of the ones that I wrote specifically for this demo real quick. But there's a Bootstrap agent called local image. Let me just CD into that local image directory. I actually have a CIF file that I've created here. And if I look at the local image definition file, the Bootstrap agent is local image, and you give that either a relative or a full path to a CIF file, which is on your local host. And then after you do that, you can use it as a base in your definition file. So that's pretty cool. A little less reproducible than some of the other methods that we're showing here, but could be handy if you're doing development. Okay, now all the different Bootstrap agents that I've talked about so far, you start from an existing container, right? And there are some drawbacks to doing that. What if you want to create a container and you don't want to start from an existing container? You want to start from, something else. Maybe you want to start from a mirror URL from which you would get the components for a file system for like, Rocky Linux, for instance, or maybe Ubuntu or Debian or something. How would you go about doing that? Okay, well, let's take the example of Rocky. Let me CD up one level. So the way that you would bootstrap a new Rocky Linux image, not one that's based on a container, is that you would use yum to create your file system. Now, this is going to run outside of your container, obviously, because it's got to put this thing together and make a container for it to jump into. So for this to work, you have to have yum installed on your host. Once you've got the yum bootstrap agent, you get some different keywords that you can add to your header. So here we've got the mirror URL keyword, for instance. And this include keyword actually takes the configuration of yum on your host system and puts that into the container at runtime also, so that you'll have a functioning, usable yum in your container. And that's something that's a little bit specific to RPM-based images that you start from like a mirror like this. So this is kind of cool because if you think about it, almost all of the container ecosystem depends on existing containers and depends on starting from existing containers. And when you start from an existing container, you have to trust a bunch of people, right? You have to trust, the entity or the organization or whoever that built the container, that they didn't put anything malicious in it. And then you also have to trust whoever is administrating wherever the container is owned or wherever it's stored. So when I download a container from Docker Hub, I'm like sort of implicitly trusting that the developers of Docker Hub itself are, putting some security best practices in place and are themselves not malicious, which I'm sure they're not. But, there's a little bit of trust that goes into that, right? And says, I've grabbed this container from this third-party registry, and I trust that everybody protected it, did what they were supposed to do to make sure it doesn't get messed with. And I'm trusting that whoever originally created this container didn't mess with it. And so if you do this instead, really the only entity that you have to trust is whoever's maintaining these mirrors, right? Which you ultimately have to trust one way or another anyway. So this is, if you're paranoid, which everybody ought to be, right? This is a much kind of cleaner and better way to start off building your containers. And you lose, though, some key features by doing this. It becomes clunkier and harder to write your definition files. You can't use things like signatures and things. You can't have your containers encrypted. So I'm going to show you, there's like a compromise that you can do where you can basically build yourself your own library of containers to start off with from mirrors. You can sign them all to make sure that they don't get tampered with. And then you can use those as your base containers that you start off with. And you can always, be pretty well assured that you're starting off with a good, nice, clean container at the beginning of your build. All right, let's look at, so if you wanted to build a Debian type of container, like Ubuntu, for instance, that looks a little bit different. So in that case, instead of using yum or instead of using apt, there's actually a tool called DE Bootstrap or Deb Bootstrap, which you would use to create your file system. And this is specifically a tool created programmed to create Debian style file systems. Once again, this has to be installed on your system, which is kind of weird. So I'm running, a Rocky host system here, but I actually have the Bootstrap installed on it, which is kind of strange, but you can do and works just fine. And then this is kind of like the final thing I want to show. And I see very few people using this, but it's pretty cool. One of the community members contributed this code a long time ago and had this great idea. And so I want to show you a Scratch build. This is hardcore. You got to really know what you're doing to do this. So let's say there's two here. There's Alpine and BusyBox. I'm just going to look at Alpine really quick. So there's this Bootstrap agent called Scratch. And what it means is give me an empty container that doesn't have anything in it. Give me nothing. And then I will do everything. And this, going back to Jonathan's question, here's where the foreshadowing pays off, is where you would actually use something like setup. Because remember that setup runs before your container gets downloaded and it runs on the host system. In this case, what we're doing is we're defining an environment variable, which is a URL. And then we're curling that URL to grab this Alpine file system. It's a tarball. we're untarring it, and we're sending it to this special environment variable called Apptainer root fs, which is only available at build time during the setup section. And what this does is it basically extracts the root file system into our container. And then we're just excluding the /dev and etc hosts files and directories because we don't need those for our container to work properly. So with this Scratch Bootstrap agent, you can basically install anything you want inside of a container. You could go through and use DE Bootstrap, Yum, any of the other. You could use Pacman. You could use basically anything that you can create a file system with, or I mean, it doesn't even really have to be a root file system, but your container is not going to work very well under Apptainer if it doesn't have a root file system in it, probably. Although it might. But in any case, this allows you ultimate flexibility. This is like, however you want to build your container, go ahead and do it. All right. So let's take any questions, and I just want to talk about one more thing. So is there any questions on Bootstrap agents?
I haven't seen any yet, Dave.
All right, cool.
It's very cool. I haven't seen a lot of that before, so that's very cool. Thank you.
Yeah, so I lulled you in, I started off really, really slow, and then I got into some of this crazy stuff.
You mentioned that you lose out on some functionality like signatures when you use, say, a Yum Bootstrap agent. Why is that? That surprises me that you wouldn't be able to sign a container like that.
Oh no, so and that's a great segue. That's exactly what I'm going to get into. So it's not that you're unable to sign a container like that. You can easily sign a container like that. In fact, that's a great thing to do, but you can't. You can't.
Oh, the point of origin doesn't have a signature. I see.
And I hesitate to say that because it does, right?
Yeah, the repository will have signatures and things like that. But yeah, okay.
Right. But it takes a long time too. It takes, if you could just download a CIF file that already has the root file system already in it versus building from scratch the root file system every time you want to build a container. You know what I'm saying? It's just a lot easier to just download the existing, especially if you got like a slow internet connection or whatever. It's a lot easier to just start with an existing root file system. So to do that, what you can do is you can just create. And this should be like practical, real world kind of stuff, right? So when I was at the NIH, one of the things I was kind of tasked with is let's come up with a library of base containers that we can vouch for, that we know, right off the get-go don't have malicious code in them, and we'll use those as as the base containers that we build our containers off of, right? And so those still exist. They're up on the library. So if I do something like Apptainer pull, all right. So I've got this container up there. I've got it in a collection that I call secure. Okay, and then if I let's see what's it named. I did this into the repo. I didn't mean to do this in the repo, but in any case, here's what it's named: CentOS8latest.cif. So I can look and see Apptainer inspect def file. Okay, so this is the definition file that I used like 2 years ago to create this container. I built this specifically right from the mirrors, so I didn't use any intermediate container that somebody else had built. And I didn't even use like a container registry. I just used the mirrors. Well, how do I know? This thing's been sitting on a third-party registry, though, for the past 2 years. How do I know that this container hasn't been tampered with? Well, that's where your verify command comes in. So I can verify, I can go, look up my key and I can verify that that's the signature that I signed this thing with 2 years ago, which it is. And so because it is, I know that this container is a bit for bit reproduction of the one that I made a few years ago and that it was made, from these mirrors. And so I don't really have to trust anybody when I use this as a base container, I can be, pretty confident that this is clean and it has in it what I know is supposed to be in it, to use this as a base container. And I've got like a couple of CentOS containers of a couple of different versions, a few Ubuntu containers, a few Alpine containers. So all those can be used as nice clean base images to start off with. Cool. So any questions about that workflow? Oh yeah, and one more. Let me close the loop though, because how do you check the signature when you do a build, right? Do you download the container and then do a container, or then do an Apptainer verify and then build from the local container? No, you don't have to do that. So right there in the definition file, you can put that fingerprints keyword, and this is really nice because Apptainer is going to bomb out immediately. It's not going to try to run anything if it sees that this container is not what it thinks it's supposed to be. So it'll just run the verify command on your behalf at build time. And, as long as the container checks out and it's good, it'll go ahead and build your container. And then you'll have this record right in the container in the definition file of, what you built, where you built it from, what the fingerprint was, and everything you need. All right, cool. That hopefully that closes the loop.
I think so.
Okay.
No, it's fantastic. Thank you. So we don't have any questions, and I haven't seen any come in. I'll ask anybody have any things they want to say before we leave. We're right up on time. Closing thoughts, Jonathan?
No, this is great. Like you said, Zane, a lot of the specifics of some of the outside Bootstrap agents were something that I hadn't seen. So thanks for going over it with us, Dave.
Absolutely.
You got it.
Yeah, absolutely. Agreed. There's a lot of info there that I didn't know so far about like those Bootstrap agents, and yeah, just a lot of great little tidbits in general, Dave. So thanks for bringing that.
Yeah,
appreciate it.
Classic LOL cow. Awesome.
Thanks for the comments, Ryan. Well, on that note, we will go ahead and wrap up. Dave, thank you very much. Join us next time in 2 weeks for the next of this series of education with Apptainer, if I believe that is the way that it's going to go. So like and subscribe, and we will see you soon. Thanks, guys.
Right. Thanks, everyone.
Bye, everyone.